Just your screen is visible. Nitin, we cannot hear you.
It's my mistake. Sorry.
Yeah, now it is okay. Yeah.
So we are based out of Delhi area, and as a company, we now have 400 installations across India and 25 across 12 countries. And the company focuses only on solar cooling solutions related to cold storage, milk coolers. So these are the few applications where we work. So few of the prominent installations which I would like to mention is we have work a lot with Amul in Gujarat, and we have also worked with US Department of Agriculture. So these are the two important ones. And the third is that most of the milk of Purbi Dairy, which is in Assam, the largest cooperative of Northeast India, is cooled by us on solar. And so, so this has been so solar cold storage has been in India for now, I think, for 15 years. And one of the very few important improvements in this industry have recently happened. So one of them was that earlier solar cold storage was not part of any Ministry of Agriculture subsidy guidelines. And now in the coming financial year, which is starting from 1st of April, solar cold storage and also grid cold storage with thermal energy backup is part of the new guidelines of Ministry of Agriculture. So that is one very important point. And so in fact, a lot of changes have happened in the new guidelines. One of them is that they have, from a cost norm perspective, 5 lakh is the cost for a conventional cold storage, and which is based on grid, and backup is through diesel generator. And the cost norm for thermal storage and grid-based solution, and which can work on 8 hours of grid any time of the day and will not require diesel generator, is about 8 lakhs. And the solar cold storage cost norm is 20 lakhs. So this is one update I would like to give on solar cold storages. So one of the feature with these cold storages have, which is like temperature range, right? So they can go from 4 to 20, which is primarily meant for vegetables. Fruits, it can go to 1 to 15. Then -5 is for fish application, and then frozen application. So the good part with solar cold storage happens is that they have a multi-chamber. So one of the main challenge which we have seen in the industry is this slide. So this is the guidelines by ASHRAE. So every commodity has a different requirement. Some of them are ethylene sensitive. Some of them are not ethylene sensitive, and their temperature requirements are also different. All of them cannot be stored in a same room, and they will go bad. So this is very important consideration for post-harvest and cold storage requirement. So this is one of the primary reason of having multi-chamber in a cold storage. So another thing which is very critical is that why are we okay? So first of all, why do we require solar cold storage? So grid is there available. So one of the feedback which we have received from the farmers was grid is not available reliably, and if it is available, it is available only for 10 to 12 hours because there is an agriculture feeder line. This is one. Second is that if the grid is available, then there is a power cut of about 4 to 5 hours. So in those 4 to 5 hours, there is a requirement for diesel generator. So to eliminate the diesel generator, there is a technology which is thermal storage. So thermal storage stores the energy in form of water and ice, and that provides cooling instead of diesel generator. So that is the reason why. solar cold storage is beneficial. So this is one. So the same technology can be also integrated with the milk coolers. So this is one example where the cooling is very fast with the milk. Traditional ISO standard cools milk in 180 minutes, and thermal storage milk coolers cools within 120 minutes. And higher quality of milk means you have more profit. Both of these, solar cold storage and milk cooler, can be combined. That is the new innovation from our company, that you can combine both of them. And combining means the same solar panel will be used for cold storage and for milk cooler. So the energy will be shared between both of them. So that is the key advantage of having a dual feature where a solar cold storage and a milk cooler can go. So this I have already talked about the need of multi-commodity cold storages, where the same solar panel, same compressor provides cooling in either chamber. And one room can be meant at a different temperature, and another will be at different temperature. And these are the National Horticulture Board, the way they have categorized different horticulture commodities between 7. So there are 7 commodities, and all of them have different requirements. So this I have already talked about. So also all of these cold storages do have a remote monitoring feature, and with the remote monitoring, all the critical alerts can be received through email or SMS, and the energy stored in the system can be also regularly monitored. So this is our joint patent. This technology is based on a joint patent which was done with National Institute of Solar Energy. We are just showing this. This is our factory. So we have a 1.5 acre factory and about 420 installations, and few countries are listed here. So this is so when Ministry of Agriculture launched their scheme, so they also wanted to have a demonstration site. And so this was a GIZ project where they shortlisted the companies based on the lowest price bid. So Inficold was lucky to be shortlisted for this prestigious project. And this is an installation at headquarter of National Horticulture Board, located in Gurgaon. So this is a demonstration site where and meant for FPO training. If people want to see how a solar cold storage ideally is installed. So this system is a multi-chamber. This is an empty room, and there are 2 rooms inside this. Another example where so here I will just share a lot of photographs and discuss or explain the various use cases. So this is a very good example where an Indian company and a Make in India technology was adopted by US, and we started working very closely with United States of America Department of Agriculture in Malawi and Kenya, and this particular application was meant for sweet potato. So sweet potato, shakarkandi, so that can be stored for 6 months. So at 14 degrees Celsius, if you do proper drying, so it can be stored for 6 months. Another interesting part of this project is that this project is also meant for trying out onion. So we have done about 4 installations in Kenya, and 2 of them are used currently for testing onion storage. And so in this particular, it's a multilateral project where US government is involved, North Carolina State University, then Kenyan government is involved. So we are also quite learning a lot from their expertise on both onion and sweet potatoes. This is another example. We have a couple of installations in Bihar with couple of FPOs, where the end user is generating revenue of more than 1 lakh. I would say not revenue, profit of more than 1 lakh every month. And these are located in Darbhanga and Madhubani. And these FPOs are part of the cooperative union. So Bihar has 3 cooperative unions, and these 2 FPOs are part of them. And now they are planning to install 50 more such systems. And one of the very important understanding which we got from these FPOs was that they started also becoming a trader for other commodities. So they were selling fruits. They were producing primarily vegetables, and based on their experience, they started purchasing fruits from other FPOs in other states. So apple from Kashmir, oranges from Nagpur, banana from Assam, and they became a trader for their entire village. And we started seeing daily 1 to 2 tons of commodities getting sold at these 2 locations. And based on the feedback, now they are working on another 50 installations. And and another thing which we realized means these are a lot of people have a confusion that solar doesn't require grid. Solar will require grid little bit in the rainy season, and these 2 particular systems which are very very heavily used, their monthly consumption of electricity is less than 6,000 rupees. So 500 rupee every month on an average basis, right? So little bit of grid they use. Another very beautiful example which we have seen in Raurkela. So one of the main challenge with FPO or a farmer producer organization is market linkage. So if you give a cold storage to an FPO in a village, still it will not solve their market linkage. So in this particular case, the Raurkela Municipal Corporation in Odisha, they gave land to the FPO in the mandi, in the city mandi. So at 5 different mandis, FPO was given land, and E-Cool Bazaar was developed. And these are large size systems, 30 metric ton, 3 chamber, 1 chamber used for apple, another chamber used for fruits, vegetables, and third room used for milk and other commodities. And so FPO was making money by selling these directly to the end user in the city. And what the last update which we got was their revenue was close to 25 lakh per month. And with, I think, couple of lakhs of profit also. So this is another example how an FPO can use these solutions. This is an example where our solutions have been installed by Indian military, and this is a photograph of Ladakh. And a lot of people ask me why Ladakh. Ladakh is cold. Why do you need cold storage in Ladakh? So this is a cold storage which is all weather. It do cooling in summer and it do heating in winter. And it is installed at a border for the food of the for the army. So in winter it will not let food to get frozen. It will maintain it at 4 degrees, and in same it will in the summer it will maintain at 4 degrees. Now we are doing a lot of such installations in northeastern region of India border, where there is no electricity available, and the food supply is only delivered through helicopter in every 14 days. So the soldier doesn't get good quality food, and we are expecting with these installations their food can be preserved for at least 14 days. So this is an example of first ever FPO of Karnataka, Sahaja Organic, and this happens. This FPO was referred by PM Modi in his Mann Ki Baat couple of times, and this is a very old system. This was installed 5 years back, and this is an organic FPO, and they are using it for multiple commodities. One room they are using for storing potato, and potato requires a different temperature, and never the room is opened on a daily basis. A smaller room they use for storing day-to-day vegetables. And the third room they are using to store tamarind or spices. So this is one example where multiple different rooms in a cold storage really helps in increasing the utilization of the system. The new system is installed here. Just this is an old photograph. So they have installed the second system about a year back, and now they are requesting for five more systems. This is Mizoram. So this is Mizoram, right? A very high rainfall area of India, and these systems are very specially designed, where the thermal backup and the solar panel and compressor sizing was done in a very different way. And this is a system installed by Ministry of the Mizoram Institute of Science and Technology Department, and they are operating it for last 2.5 years, and they are testing different commodities, oranges, tomato, pomegranate. So they are testing a lot of commodities there. So we work a lot in Nagaland and the entire Northeast belt, and this is one example in a very difficult terrain of Nagaland, where there is no, you cannot bring grid, but you can bring solar, and as you can bring solar, you can also bring cooling for them. And this is what we are learning from the farmers is they are using it for multiple different applications. They use it for their oranges, dragon fruit, naga chili. One interesting application which we realized from them and which we were not expecting was tea leaf. So tea leaf is plugged, and then while it is dry, while it is green, it can go bad. So immediately it need to be processed. And a lot of time there is a rain, so you cannot process them, and then it goes bad. So the farmers are storing fresh tea leaves in the cold storage for a few days, and after that they are getting enough time to process it. This is another example where so this is a photograph from this is from Kashmir, and these are apple trees. So we have installed a couple of systems now in Kashmir with 1 degree application, and apples is used for apples. So so a lot of people have yesterday one person asked me, Kashmir is cold, why do you need a cold storage for apple? So an apple harvest time is close to November time frame. So but I asked him one question: have you ever eaten Indian apple in off season? So his answer was no. So what happens that every 2 degree reduces the life of a commodity by half. If apple can be stored at 1 degree for 6 months, its life will go down to 3 months if it is stored at 4 degree. And if it is stored at 10 degree, then its life will shelf life will go down to one month only. So temperature is very critical, and a lot of people don't take it seriously. So this is the reason why Indian apples are not available in off season. And this is one example where apple immediately plucked from the trees is stored inside, and it stays there for a couple of weeks. And when the farmer get enough supply, he takes it to the bigger market. And this is a multi-chamber cold storage. And the reason is apple harvest ends by November, December, and plum harvest starts by December time frame, and both of them doesn't like each other. So you cannot store plum with apple, and both of them will fight, and both of them will go bad. So apple is stored in a different room and plum is stored in a different room. This is one advantage. Second advantage of multi-chamber is if one room is not utilized, you can shut off the cooling of this. All the energy will be going here or will be used for this cold storage or this chamber. So that is the advantage of multi-chamber also. This is another example of solar cold storages where these are used for vaccines. This is India's first vaccine cold storage, done 1 year before COVID. It's a 5-year-old installation, a 4.5-year-old installation. And now we are doing a couple of more installations for similar systems. So what I say is that these solar cold storage technologies are now military grade and they are also medical grade. So they are approved by both of these applications, and they are quite viable for fruits and vegetables. This is India's largest solar cold storage. It's a very small system, I would say, from standards perspective, only 50 metric ton. And this is a very famous FPO in Navsari, with Vasudha. They are using it for cashew, ripening of mango, and very good XP. Very good story about this FPO is, after they have installed the system, only thing why they are not happy is every year they get a raid from electrical department, and the electrical department feels that they are stealing electricity. So earlier their bill was 2 lakh a month, now it became near to zero. So that is the reason. So why they are not right? Why they are the reason why it is troubling them. But this is a very old installation done 5 years back, and as we speak, we are also doing world's largest ever solar cold storage, which is going to happen in India, and it is expected to get commissioned in next 3 months. That is, it is 100 metric ton solar cold storage meant for seed potato, and it is getting installed in northeast of India. Another example where solar cold storage also find application for pulses. So your Indian pulses, lot of time is banned from exports. There was a recent news that Indian red chili, the rejection rate from Europe is very high, and one of the reasons is that. So one of the reason is storing pulses and spices not in cold and dry environment. These are stored outside, and to make sure they can survive the hot and humid climate, people put insecticides and pesticides, and those lot of time get the consignment get rejected in the export. So this is one example where organic pulses in Uttarakhand are stored in a solar cold storage. This is one of our oldest installation, done 6 to 7 years ago. And one of the feedback which we got from the end user is that the color of the pulse of this Rajma has not changed. So the old Rajma will have a faded color, and the Rajma which was stored inside the cold storage, the color is as good as the new Rajma. So that is another use case. So this was my last slide. So I will be happy to answer your questions. And so I think there's time. So let me also share one couple of more documents, and which you can. So these are see one of the challenge in solar cold storage industry was lack of technical specifications. So the government of India was kind enough to publish the technical specifications and to bring standardization in this industry. So this is a document which can be read and online, and it's quite a long document. I will just focus on few key important points here. So one of them is that this is right. So this also has the commodity temperature ranges, right? Holding time, shelf life, temperature, and which lot of time, right? People are not aware. And these specifications are provided by Ministry of Agriculture. So this is one very good important document which people can refer for installing cold storages. So, and these are different commodity type. So you cannot store this with this type, right? So this is one important part, and there are a lot of different type. I think a total 7 different types. So this is one part, and second is the minimum specifications. So from performance wise, the pre-cooling capacity of the cold storage, what it should have. A lot of companies, they undersize the solar part, and then they will sell it for a cheaper price. So to avoid those kind of confusions, and a lot of people also, they undersize the room itself. So a 5 MT cold storage will be known as 10 MT cold storage. So they have standardized the internal volume of the room, the puff panel thickness, and then for different applications, what shall be the thickness of the puff panel, and then the compressor capacity. How much would be the compressor capacity for these cold storages? Then thermal backup. So thermal backup is 1 day or 2 day. So 2 day is the thermal backup, which means if there is no sun, then the system can run for 2 days. And second is 1 day. If there is no sun, the system can work only for a day. So this is what they have recommended. And then the solar panel capacity, battery capacity. So these are the few important points which Ministry of New and Renewable Energy has highlighted. And then another is prevent the discrepancy. They have also provided a template to provide technical specifications. So this template means what we recommend to the end user, that now you have a very transparent template which should be used, and which the end user should ask the vendor like us to provide the details, because this also give lot of clarity on the system overall efficiency. So it's a very detailed technical specification template which they have highlighted in the document. And later there is the testing procedure. So till date there is no accreditation laboratory which can do testing on solar cold storages. People were getting it tested by like on ad hoc basis. So now they have also released the testing procedures. And then this is the new guidelines by Ministry of Agriculture. This is published by National Center of Cold Chain Development, NCCD, engineering guidelines, and this is a very detailed 300 pages document where they have talked about the guidelines for every possible application in cold storages, right from small size to large size. This guidelines also have solar cold storage as one of the component, and this guideline also has the cost norms. So the cost norm for example, I think I can find it out from here only. So cost norm for, let's say, no, I think, yeah. So cost norm for, so they have provided different cost norms at the back side, and so they also have their own annexure for the technical specification which are required for availing the subsidy from National Horticulture Board. So these are the different annexures from them. And in this particular, so this is the annexures, and just before this is the cost norms on this. And these two documents can be referred for availing the subsidy on cold storages. So thanks. So I can take the questions. Just a sec. Just give me a.
Yeah.
Hello.
Yeah. Yeah, Mr. Nitin, I have one question. Yeah, are you ready for the questions? Yeah.
Yes, ma'am. Yes.
Yeah. Yeah. So my question is like, can this solar cold storages be used in hotels and hospitals also? Because what you have showed, that is like, say, for agricultural produce or I mean, these are the standalone applications which are just the cold storages, right? So, but in case like, say, hotels and hospitals or other facilities, so they may also require this cold storages, especially the food industry. So can these solar based cold storages be used there also?
Yes, so we have so one of the slide which I showed was a solar cold storage at Kozhikode Medical Hospital, Medical College
Yeah.
Hospital, and
Yeah.
which is used currently for storing vaccines. Another installation is happening in Calicut in Kerala, and which is a cancer hospital where cancer medicines will be stored in for an entire hospital. We have just done the third installation in Mizoram, which is the Mizoram State Hospital. So that is the largest hospital for Mizoram in the capital Aizawl. So these systems are typically used for vaccines on large size systems, right? Large requirement. As we speak, our company is developing small refrigerators based on solar and with ice backup or thermal backup, which can provide 5 to 7 days of backup in case of grid failure. So in the case of vaccines specifically, there's a very strong requirement of having cooling autonomy of couple of days. So that is one. Second is on the hotel side, we have not done an installation with a hotel. We have done one installation which was done 7 years ago at Gokarna Temple. So, which is a very famous temple, Gokarna, just below Goa in Karnataka.
Mm-hmm.
So, at that temple, their food for prasad is stored. The pre and post cooked food is stored inside a cold storage, and it has been used for about now 6 to 7 years. Another application where we are doing an installation is tribal schools. In tribal school, which are these schools are in-house schools um, where the the students are staying at the school itself, and there are a lot of incidences where there is a the news of hospitalization because of food poisoning comes. I think every month I have seen such news. So we are doing a couple of installations in these tribal schools, and then there are these few questions which I see here. So I will so shall I go through from these?
Yeah.
Yes. So
Sure. You can.
so first question is, if we evaluate the COP of the cold storage compressor, what is the range? See, first of all, the compressors used in these cold storages is a similar technology which is used in a traditional cold storage. So the COP or the efficiency is quite similar, and the COP changes with the temperature range. If temperature requirement is lower, then the COP, the coefficient of performance, will be lower, and if the temperature is higher, then the COP is higher. And in very specifically, solar cold storages use variable speed compressors, and variable speed compressor have higher COP because they most of the time they work on part load. So the condenser becomes oversized, and which means your condensing temperatures becomes lower. So these cold storages they try to match the solar generation. If solar is more, they will run at more speed, and if solar is less, they will run at lower speed. And so we cannot compare them with HVAC compressors. And the reason is that HVAC compressor would be running at 7 degrees Celsius evaporating, and any cold storage application where will require evaporating temperature to in the range of -2, -1, because the cold storage are typically used for at 5 degree. So the compressors which we are using are from traditional companies like, so we use semi-hermetic compressors, which are companies like Bitzer, Frascold, Danfoss has recently bought a company BOCK. So these are industrial grade compressors which are typically used in industry, and these compressors have duty cycle of even 100%. So what it means is that these compressors can run continuously for years. So these are very highly reliable compressors. And also another interesting part is these are repairable compressors. These compressors can be repaired. HVAC compressor can never be repaired. The another advantage of these compressors are they are very rugged. So each compressor will be like 60 kg, right? So they are more like an engine. And from an energy efficiency perspective, the motor is not getting cooled by the refrigerant. So motor is sitting outside, and which is cooled by the air. So the COP becomes about 10 to 15% higher. Then another question is solar PV integrated technology good for dairy and ice cream application? So we are already, so we need to first understand the application. Is it farm gate to cool the milk when it is taken out from the udder, or the application is at the end? End means at the client side or at the consumption side. So in the dairy application, 50% of energy consumption happens at the farm, at the village, where milk once comes, it need to be cooled immediately. And in those cases, solar technology is very viable for dairy application. And one of the primary reason is that these solar systems have a thermal storage, and thermal storage rapidly cools milk. So milk can be cooled within 1 hour from 35 to 10. In a traditional milk cooler, it takes 2 hours. If milk is cooled very rapidly, then the quality of the milk is very, very good. So I always give one example. When I was staying in US, I never had a milk curdling issue. Milk was kept in the fridge and it never went bad. In India, milk goes bad every month. The reason is very simple, that in India, milk is not properly cooled. And when milk is not properly cooled, it will have higher bacteria content. And once bacteria has grown, you cannot stop it. It will grow, it will multiply. Its multiplication becomes slow at lower temperature, but it will still multiply. So that is one application. And second application in ice cream industry, which we are seeing and which we are working upon, is every peri-urban or village area, if it has an ice cream distribution center, they need contingency from grid. If there's a grid failure, all the ice creams will melt and there will be a very high loss. So thermal storage is an automatic solution where automatically, if the temperatures are not meeting, it provides the cooling. So that is one example for ice cream. And second example of ice cream is ice cream cart. So today, ice cream cart, the vending machine, which from where we buy ice cream, is currently powered by electrical lead acid battery. So those can be solarized, those can have thermal battery. So there are few different applications. How thermal storage is designed and it works. So see, thermal storage is a very old technology, and a lot of people don't know. Burj Khalifa also has a thermal storage for air conditioning. Taipei 101, which was one of the tallest building in the world, and now it is the tallest building for Taiwan. It also uses it. Stanford University, Orlando Airport. So thermal storage, what it do is it takes PCM, and the most simple PCM is water. So water is converted into ice, and from that ice, cooling is provided. So the application and the case studies which you have mentioned about on thermal storage. So I would say applications is it has multiple applications. Burj Khalifa uses thermal storage to meet their demand of cooling. So suddenly there will be a lot of footfall from 5 o'clock to 7 o'clock. Their air conditioner compressor sizing will be very, very big. So what they do is they use a small compressor. They make ice 24 hours, and from this ice they are providing cooling. This is one application. Second application is, for example, um, these days one of the main challenge for a factory or industry is their peak demand of electricity shoots up, increases. So when there's a peak demand, shut down the compressor, cooling is coming from thermal storage. And when there is during off-peak hour, use thermal storage. That is the second application. Third application is if peak power is very expensive. In India, peak power is only 1 rupee expensive, but in outside countries, in US or Australia, the price difference is 1 rupee versus 15 rupees, 15 times difference. So when electricity is 1 rupee, use it to make ice or charge it to charge it to make thermal storage, and then use it when the electricity is very expensive. Another application is in a village, there is no power. Now people will be use diesel generator. And now the funny thing with diesel generator has happened is there's a very strict pollution norms. So if someone is using a diesel generator, it need to be replaced every 4 years. Thermal storage is a mechanical device. There is no replacement, just a fetching material. So replacement is not there for 15 to 20 years, and it's a very economical solution. And how it is designed is these are every company has their own designs, and so some of them use ice packs, some of them use bulk system. So, now the question is how much would be the cost of cold storage with solar? So this is a very tricky question, I would say, because lot of time the cost depends on the application. So if the application is storing grapes, then the requirement of solar and the requirement of compressor is half to if the application is to store tomato or daily vegetables or strawberry. So that is one comment I would like to make. Second is that if we look into the cost norms of Ministry of Agriculture for a 10 metric ton system, so 10 metric ton system norms is 5 lakh rupee for conventional cold storage. And by the way, Ministry of Agriculture has done very, very good thing now. They have disallowed R22, 404A, and any refrigerant having GWP of more than 1500 for conventional cold storages. So 5 lakh is the price for conventional cold storage. 8 lakh is the price for thermal storage based system, grid with thermal storage. And 20 lakh is the price for solar with thermal storage based solution. And this is the cost norm by the government of India. And if we increase the size of the cold storage, it typically is not double. It becomes like 1.5, 1.6 times. But a lot depends on the application side. And then I have one raised hand. Mr. Anish, sir, so this is you can ask your question. Allowed to talk. Yes.
Yeah. I am allowing him to talk so that he can put up his question. Yes, Mr. Anish, you can put up your question if you have.
Yes. Actually, can you hear?
Very well, sir.
Yes, we can hear.
Good evening, sir. Sir, basically, I'm an energy auditor. So, we had recently conducted energy audit and performance study on cold storage for an FMCG industry. So they were actually storing different products from different vendors, like ice cream, Sub-Zero applications are there. Then they were storing fruits, dry fruits. Then they were storing some spices. So what happened is we had evaluated the COP of these compressors. So as you rightly told, with the temperature if is reducing, the COP will be less. Like actually we were also getting less values, but the compressors are all new compressors. So they were VFD was not there. So we advised VFD. So the issue is that this is a reciprocating compressor. So in that, if we reduce the speed using VFD, they are telling that that oil pump need to be added. So otherwise, the oil pumping issue will come. The cooling will be affected. So that's why I asked that question regarding the
Okay.
COP. Yeah.
Okay.
And my
So
second question is, yes, sir.
so
Tell me.
let me first answer on this.
Yes.
So one is that you need to make sure the moment you mentioned oil recovery or oil return, you need to make sure if that compressor is allowed to operate at lower or different frequency. And if it is not allowed, don't run it. Otherwise, the compressor will go bad within a day. So fixed speed reciprocating compressors, which are black in color, like a dome, they are
Yes, sir.
right. So they will not. You cannot install VFD over it and run it at lower speed. That is one. And you need to go through the brochure of that, or write the catalog of that. That is one. Second is that VFD will only help in power factor, about 5 to 10%. The third part is that if the efficiency is low, then most important thing which need to be looked into, the condensing temperature and the ambient temperature, the difference of those. Lot of time the condenser is not cleaned or condenser is undersized, and which typically will increase the condensing temperature, and that will reduce the system efficiency. My rule of thumb is that the condensing temperature and the ambient, the difference of them is less than, it should be less than 10 degree. A 10 degree Celsius less difference between condensing temperature and ambient is very good. So that is one, and that can give you an idea on what is the primary issue. Second issue can be your refrigerant might be low. The third might be that there might be some there will be some non-condensable gases present in the system. And fourth might be your evaporator might be undersized.
Okay, I think that evaporator undersize issue was there that we pointed out, and the condenser temperature that you are meaning to say that condenser approach, right? That actually that was within 8 degree or something. So that was the issue. Okay, sir. Anyhow, it was a very good insights from you. And the second last question from my side. Actually, I have typed in the chat box that we have done energy audit for dairy, some bulk milk chillers. It was a cluster study we did for one industry called Milma in Kerala. So they are a very it's a very PSU. Milma is basically a PSU, state government undertaking. So they distribute milk statewide. So the milk coming from farms, they used to store in societies. This bulk milk cooler is there. So around 4 degree they store it there. From there only it goes to the Milma dairy. So what happens is here we lot of places we have seen the condenser side they are recovering heat from the condenser and producing hot water. So why hot water is produced? Because each time they are recycling the milk, they need to clean the container to sterilize it. So when we evaluated the COP and KW per TR, there also it was less actually. Is it a good practice at energy efficient point of view, or let the air go out, the hot air go out from the condenser, which is good?
Okay, so first of all, the reason they are using heat recovery is you're using that waste heat for other application, and that is always it is more energy efficient. Means otherwise they would have been using electric geyser.
Yes, correct. Electric geyser was there.
Right. So instead of using electric geyser, they are just using free electricity or free heat, I would say, right? So efficiency is always good for that application.
Okay, so that is a good practice. Okay, sir. Okay.
Very, very good practice. And in dairy, right, all cooperatives, they follow ISO 5708 class 2 standards, which are very, very stringent. And in India, they are controlled or managed by National Dairy Development Board. So,
Yes.
right, so it's a very standard practice by them. And then there's a question on what would be the size of Anish sir, any further question?
No, sir. Thank you, sir.
Yeah,
It was
I think there are other
question was
questions.
also nice.
Let's take
Thank
a
you, sir.
Yes. So one question is
there are other questions also.
Yes, yeah. So one question is, what is the size of solar panel per ton? So I have shared this MNRE guidelines, and which shows 7 kilowatt panel for 5 MT, 12 kilowatt for 10 metric ton, and so that is the typical size of the solar panel required per ton. And then other question is how these are energy efficient, and which refrigerant is we can use it to make it energy efficient. So okay, so first of all, see, we are only using solar instead of electricity. So right, so energy efficiency of a grid-based cold storage or a solar cold storage is quite similar. The good part with solar cold storage is that as solar is expensive, we need to utilize it in a very economical manner. So the system uses a lot of energy efficient components. So it will have a suction heat recovery heat exchanger. So it will. So those are the kind. It will not use capillary tube. So it will use external thermal TXVs. So those are the few comments I would like to make. From a refrigerant side, so energy efficient. So CO. So okay, I will give you one example. Right, CO2. CO2 refrigerant, people believe it is very energy efficient, but the efficiency is half. COP is half. Right. So refrigerant selection depends a lot on the environment or the GWP, the global warming potential of the refrigerant, and COP of most of the refrigerants is quite good. So, for example, 407F, 448A, they have quite good COPs. So another question is, it was mentioned one of your slides. Yeah, so we have 25 installations in other countries. So we have installations in Philippines, Bangladesh, Nepal. Kenya is the largest. We have 10 installations. Sudan, Uganda, Burundi, Senegal, Mauritania, Nigeria. Now we are doing installations in Madagascar and Fiji. And 400 installations in 24 states. So we are not present in...
This question... Yeah, this question is continued later. So okay. Mr. Gande is asking, like, he want to know technically and cost-wise installed storage, solar cold storages in Asian and Gulf countries where there is a huge potential, since temperatures is very high and power availability is a problem.
So Gulf countries, I would say locations where there's lack of grid. Means we have typically seen like Sudan or Egypt is a perfect example, or Lebanon, where grid is very, very bad. So we have seen a lot of interest in those countries. In Dubai kind of locations, diesel is very, very cheap. It becomes very difficult to convince the client. And then another question is it possible to retrofit VFD at cold storage? That I've already answered. It depends on the compressor. There's no a typical design how many days generally we get storage backup. So based on the MNRE or NCCD guidelines, it is 2 days, 48 hours essentially. And then so the like Bitzer make compressor that is from German make. Yes, you can retrofit them with VFD. They are compatible with VFD. Is it only for food storage? So we do have a lot of installations on air conditioners, and these are. But I personally, they don't become very cost effective in cities. They might become cost effective in very, very remote locations. And have you installed for seafood, non-veg? We have not installed a system on seafood. Right now, we are installing in next, we are doing 5 installations in next 1 month, and all of these are for -5 degrees Celsius and meant for chilled fish commodity. Heat recovery is already answered. What is the accessibility for smaller customers? So one of them, see, okay, so there is a lot of subsidies. I forgot to mention about Maharashtra. Maharashtra has a very good subsidy policy scheme which is going on right now. ADB, Asian Development Bank, is providing up to 60% of subsidy on solar cold storages for FPO, and which is a magnet project. And if someone requires support on that, right, you can email me. That is one. Second is that there are that is on the subsidy side. On the also there is a AIF, Agriculture Infrastructure Fund, which allows giving interest on balance amount at 5 to 6%, and it is also no collateral. So it is not. It doesn't require collateral. So that is the one of the main, I would say, comment on those. So there are a few schemes, and then there are a couple of NBFCs which is also supporting FPOs and farmers, like Samunati is there, Sea Kinetics is another one. So there are a couple of NBFCs who are also working with farmers on it. Yes, thanks. So this was my last.
Yeah.
Any more questions?
Thank you so much for patiently answering all the questions. Are there any other questions? I think no. And yeah. Yes, there are questions below also. So do you have any references in Saudi Arabia?
No, we don't have an installation in Saudi Arabia. We don't have an installation. Yeah. There's one raised hand from Mr. Dhananjay.
Yeah, I am allowing him to talk.
And one question is life of solar panel 25 year. So that is the standard practice. 25 years is the life of solar panels. Solar cold storage life expectancy, I would say 20 years. I have seen bulk mill coolers in India which are older than me. 50-year-old bulk mill cooler working. Means if they are properly designed, you can and repaired, right, or maintained. Means if you don't maintain them, right, it can go bad very quickly. But if they are properly maintained, the life expectancy is more than 20 years. Any change in quality in the stored as compared to fresh? Okay, so most of the milk you drink, that is not fresh, right? So most of the potato you eat, it is not fresh, right? So the use of cold storage is to right, to keep them fresh, right, or to keep, right, so they look brand new, right? They look the way they are, right? They were plucked today itself, or the apples which we eat, right? So cold storage is meant for that. It's very specifically.
Professor Gandhi, you may speak, please, and put up your question if you.
Good afternoon, Dr. Nitin Goyal. I was very pleased to hear you for almost an hour or so. I think it's always good to listen to a person from IIT and a PhD from IIT. I am also from IIT, but very old student of IIT, MTech. Okay. My question was, of course, I have asked another question, but the life of, you answered partly, the life of the solar modules is 25 years. Can we expect the life of the solar system also 25 years?
Yes, so see, solar cold storage has a few components like puff panel, which has a life of 25 years. These days, airports are getting manufactured with puff panel. That is one component. Thermal storage just has a tank, insulated tank with copper, and that we can expect for 25 years. Compressor already. So one component which is required to be replaced every 5 to 10 years is the electrical battery. So these systems have a very small electrical battery to run the pumps and fans. So that is the only part which needs to be replaced, like in a car. In a car, okay, car expectancy life is also quite long, right? So you just need to replace that small battery.
Is it a DC pump?
Can you repeat?
DC pump?
These are DC pumps are more sophisticated, but from an efficiency perspective, I would say right? For a 80 watt pump, right, you can save 8 watt. So we don't use DC pump because they are expensive, right? So we
You
use
said there is
small.
a battery. So I thought there
Yes.
is a.
So these pumps are 80 watt, right? So in
Okay.
the entire 2 kilowatt pump system, there's a small 80 watt pump, and which is AC pump.
Okay. Thank you very much. Thank you.
Yeah, thank you, Nitin, for answering all the questions so patiently and very insightful session. And definitely our attendees have benefited from this session. And whenever they work on such kind of projects, so definitely now they know whom to contact. I have already shared his email ID in the question answer box. So you may get directly in touch with Mr. Nitin whenever you have some query like this. So thank you, sir, everyone, for attending the session. I know everyone is busy in the March end activities, but still you have taken out time, your precious time, and joined the session. And it is very heartening to see that many of you are attending this sessions regularly and taking benefit out of it. So thank you so very much, and look forward to you on again the next week itself, because that being a fourth Friday, so we have a session on that day. So thank you so much, and see you in the next sessions. Thank you, Mr. Nitin, once again.
Thanks, ma'am.
Bye.
Thanks for the invitation.
Thank you, sir.
Thank you. Thank you.